Assalamu alaikum guys, welcome back. This is Shafahat Khan. Okay, again the same experimental chemistry. Let's continue. Okay, so now in this video I'm gonna talk about the techniques of drying a simple gas. Okay, how to dry a sample of a gas. So let's get started. Okay, in order to dry a gas we need a drying agent. Okay, a drying agent. A drying agent is also known as a dehydrating agent, and of course that makes sense because dehydrate means to remove water, right? So we are actually removing water, that is drying the gas or drying it out. Okay, now dry gas is essential because in experiments, if there is an impurity in the gas, the impurity in this case being water, then it can disrupt our experiments and we might not get the desired answers. So now let's read through this paragraph. We can dry a gas by passing it through a drying agent. We've talked about it. Some common known drying agents or dehydrating agents are concentrated sulfuric acid. Very important, very important, because concentrated sulfuric acid is also used throughout A levels. Okay, so you need to learn this. Definitely need to learn this this drying agent, concentrated sulfuric acid. Quicklime, which is a common name for calcium oxide. Calcium oxide or quicklime is also used for drying purposes, and fused calcium chloride. Okay, fused calcium chloride is also used for drying purposes. Fused actually means molten, but that's the name given over here. So fused calcium chloride, that's also a drying agent. Now we are gonna look at the diagrams of each of these drying agents or each of these dehydrating agents one by one, and the gases that they are used to dry. And by the way, these are the gases that I would suggest you should remember, because these are usually the gases asked in the past papers. And now, which gas to be used in which dehydrating agent? There's a simple rule to that. Do you know what? You would always use a dehydrating agent that does not react with the gas. Okay, that does not react with the gas, okay. And if the dehydrating agent reacts with the gas, then that cannot be used to dry the gas, because it would just consume all the gas, or it would react the gas, or it would impure the gas, it would contaminate the gas. So over here concentrated sulfuric acid has been shown, and by the way this setup has great importance as far as your past papers are concerned, because you will find multiple questions in which there would be multiple setups drawn for you, and you would be asked to select which of the following setups is gonna be the correct setup, or you would be asked to identify the correct setup or to draw the correct setup, etc, etc. So now guys, over here this is sulfuric acid, okay, and you've got two tubes. This is the first tube and this is the second tube. Now the first tube is the tube from which you enter the moist gas enters, okay, the tube through which the moist gas enters, and the second tube is the tube through which the dry gas, after removing all of its water, is collected. Now the moist gas, the tube that is bringing in the moist gas, it must be dipped. Okay, this is the first point to remember, that it must be dipped in the drying agent or in the concentrated sulfuric acid, whereas the other tube that is used for the dry gas collection, it must not be dipped. Okay, it must be above the level of the drying agent. This is the most commonly asked question, the levels of the tubes. They sometimes dip the second tube and raise the first tube, which is actually a wrong presentation, but that's one of the MCQ options out there. So this is something that you need to remember. Then secondly, these corks are important. There must be corks in order to prevent the gases from escaping. Okay, so now let's read through this very important paragraph over here. Concentrated sulfuric acid is used to dry most gases, including chlorine, okay, Cl2, and hydrogen chloride. Hydrogen chloride being an acid and sulfuric acid also being an acid, acid will not react with acid. So that's why the acidic gas can be dehydrated using this technique. Okay, HCl will not dissolve in sulfuric acid. It will come, it will just remove out its water, the water will dissolve, and HCl will go up, the dry HCl will go up. Okay, and chlorine itself also, it doesn't react with sulfuric acid, so that's why the water is left behind and chlorine, dry chlorine, moves out. These are the two classical examples, but it can be used for many other examples as well. Then however it can, okay, dry ammonia. Okay, I would like you guys to pause this video for a bit and just think on it. Why can't dry ammonia be used? Ammonia is a base. Okay, it is a basic gas, and bases react with acids to form salts. Remember from your lower classes that bases can react with acids to produce salts. So we don't want that reaction to occur. We want a dehydrating agent that does not react with ammonia. So ammonia, since it can react with sulfuric acid, so is not dried using this technique, because all the ammonia that you enters will never come out. It will react and will get consumed over here. Okay, because it reacts with ammonia. That's the point. Notice that the tube introducing the gas is immersed in the acid while the exiting tube is not. See in red, they've written it in red. The very important point has been written over here, outlined in red. Okay, drying a gas with concentrated sulfuric acid, a very important dehydrating agent. Now after sulfuric acid, let's look at the other two. This is quicklime and this is fused calcium chloride. Fused means molten. Okay, now calcium chloride that has been previously heated or molten or whatever can be used to dry most gases. Okay, now quicklime or calcium oxide can be used to dry ammonia. Calcium oxide, CaO, is a base as well, and base won't react with a base, right? Ammonia is also a base, so that's why it can be used to dry ammonia. Similarly, calcium chloride over here. Calcium chloride does not react with hydrogen, so that's why hydrogen can be dried using this technique. Again, I would want you guys to remember this, that calcium chloride is used for hydrogen. In the book, you don't have any other example for hydrogen. This is a classical example. So if these are the three options given to you on the MCQ paper, then of course I would suggest fused calcium chloride would be the best one. Okay. And now here's a quick recap question over here. Why can't chlorine, ammonia, and HCl be collected using displacement of water? Remember in previous video, we did the different methods of collection of gases. So why can't these three gases be collected using displacement of water? And the answer to that is, I won't tell you. Okay, I'll tell you. Well, but before you listen to my answer, I would really suggest you just come up with your own answer and then compare. Well, chlorine, ammonia, and HCl. Ammonia is highly soluble in water. HCl again is soluble in water, dissolves in water to form hydrochloric acid. And chlorine is also soluble in water. Since all of them are soluble in water, that's why they cannot be used. Displacement of water cannot be used to actually collect them. Okay, so that's the reason. And then okay, so measurement of gases, that's the topic for the next video. So I'll see you in the next video with this topic, inshallah, and take care till then, and Allah Hafiz.